Covalent bonds, 2.1. It's all about sharing. Of course, we're talking about electrons. In a tennis match, two players keep hitting the ball back and forth. The ball bounces from one player to the other, over and over again. The ball keeps the players moving together on the court. What if the two players represented the nuclei of two atoms, and the ball represented valence electrons? What would the back and forth movement of the ball represent? The answer is a covalent bond. A covalent bond is the force of attraction that holds together two atoms that share a pair of valence electrons. The shared electrons are attracted to the nuclei of both atoms. This forms a molecule consisting of two or more atoms. Covalent bonds form only between atoms of nonmetals. The two atoms that are held together by a covalent bond may be atoms of the same element or different elements. When atoms of different elements form covalent bonds, a new substance, called a covalent compound, results. Water is an example of a covalent compound. A water molecule is modeled in the figure below. A molecule is the smallest particle of a covalent compound that still has the properties of the compound. We'll look more about properties into chemical and physical properties later on. Question: how many valence electrons does the oxygen atom share with each hydrogen atom? How many covalent bonds hold the water molecule together? If you'll notice, we have this hydrogen atom sharing an electron with the oxygen, and this hydrogen atom sharing an electron with the oxygen. The oxygen has a total of 8 valence electrons, and each hydrogen has 2 valence electrons. The diagram in the figure below shows an example of a covalent bond between two atoms of the same element. In this case, two atoms of oxygen. The diagram represents an oxygen molecule. So it is not a new compound. Oxygen normally occurs in diatomic two-atom molecules. Several other elements also occur as diatomic molecules. Hydrogen, nitrogen, and all but one of the halogens, fluorine, chlorine, bromine, and iodine. That's group 17 if you look at your periodic table. Notice these oxygen atoms are sharing two pairs of electrons. How many electrons do these two oxygens share? How many covalent bonds hold the oxygen molecule together? The two oxygen atoms share two pairs of electrons, so two covalent bonds hold the oxygen molecule together. Notice each pair of electrons forms one covalent bond. So we have one covalent bond, two covalent bonds. Covalent bonds form because they give atoms a more stable arrangement of electrons. Look at the oxygen atoms in the figure above. Alone, each oxygen atom has 6 valence electrons. By sharing two pairs of valence electrons, each oxygen atom has a total of 8 valence electrons. This fills its outer energy level, giving the most stable arrangement of electrons. The shared electrons are attached to both oxygen nuclei, and this force of attraction holds the atoms together in the oxygen molecule. Some further reading, you can read about chemical bonds, energy, and covalent bond formation. In summary, a covalent bond is formed. A covalent bond is the force of attraction that holds together two atoms that share a pair of valence electrons. Covalent bonds form only between atoms of non-metals. Those are elements on the right, and then hydrogen. The two atoms that are held together in a covalent bond may be atoms of the same element or different elements. When atoms of different elements bond together, it forms a covalent bond. Covalent bonds form because the shared electrons fill each atom's outer energy level, and this is the most stable arrangement of electrons.